Hey, Happy New Year. Welcome back. It's time for Precalculus here. And today, we're not going to do anything new. We're just going to review what we did right before Christmas break to get it back into your mind here. So I looked at your one homework and it flagged some of the problems that you had issues with. Now, you might have not had issues with these ones. That's okay. But we'll go over them anyways and it'll help you guys get back in the swing of things here. All right, so in this lesson, we're graphing rational functions, which remember is the graph of a function that looks like a fraction here. And so for this particular one, you're just supposed to evaluate the limit based on the graph, so we don't really know what the function is. Anyhow, so this says as x approaches -2, and then it has a little sign here, okay? So remember, you want to figure out, this is describing a vertical asymptote, and you want to figure out what the graph is doing as it approaches the vertical asymptote from either the left side or the right side. Okay, now because it has a minus sign here, this minus sign means you're looking as it approaches the vertical asymptote from the left. Okay, so what you're trying to figure out is what y is doing as x goes to -2 from the left side. And you see, if we follow this, y is going down, 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 down to -infinity. Okay, this next problem, we just have to find the horizontal and vertical asymptote. Then we're going to talk about the behavior at those asymptotes with limits a little bit. So just to remind you guys, horizontal asymptotes, that's when you consider the exponents on the largest degree term here. And if the larger exponent is on the bottom, that means you have a horizontal asymptote at y equals 0, okay? Horizontal asymptotes are what we call end behavior asymptotes. You could also have slant asymptotes at the ends, SAs, or you could even have like a parabola that the graph approaches, which I'll show you guys later. Anyhow, vertical asymptotes, what you want to do to figure out the vertical asymptotes is factor the bottom. Okay, so you would set the bottom, which is x squared minus x equal to 0. And then you want to factor that to figure out what they are. So they both have a common factor of x. So you take out the x and you have x minus 1 left. Okay, so since there's two factors there, you would actually have two vertical asymptotes at x equals 0 and at x equals 1. All right, so that takes care of your asymptotes. Now, as far as the limits go, well, the best way to describe the limits is to look at the graph, okay? Well, we do know the limit, okay, we know two of the limits, okay? The limit as x goes to infinity is, of this function, is equal to 0, okay? So as the graph gets really, really big, it's equal to 0. And the same is true as the graph goes to -infinity, okay, it's also going to be equal to 0. And if you don't believe me, well, just check out a picture of the graph. So that's what we're going to do right here. We're going to check out a picture of the graph. Then we're going to look at what's going on at these vertical asymptotes as well when we look at the graph here. There's really no good way to know that unless you look at the graph or inspect it with a table, which is a pain to do. So we're going to look at the graph because that's a lot easier. So as I mentioned, you see that it's approaching 0 as it goes to -infinity and +infinity. Now, as it approaches 0, okay, so as this graph approaches 0 from the left side, the graph looks like it's going up to infinity. Okay, now what about 1? Okay, it doesn't look like it's doing anything at 1. All right, but guess what? You gotta zoom out sometimes to see the whole picture here a little better. As the graph approaches 1, it goes to -infinity, and as the graph approaches 0 from the right side, it would actually go to -infinity, okay? So, anyhow, that's basically what you would want to describe with the vertical asymptotes. Now, as it approaches 1 from the right side, it's going to +infinity, okay? So, it's kind of interesting that the graph does different things from each side. So you could kind of summarize it like this. As x approaches 0 from the left side, y is going to infinity, but as x approaches 0 from the right side, y is going to negative infinity, and then you would summarize the 1's as x approaches 1 from the left. Okay, y is going to positive, that was negative infinity, sorry. And as x approaches 1 from the right, y is going to, so it's going up there, positive infinity. Okay? So you would, of course, want to write it more neatly in limit notation, but that's just the quick synopsis of the answers there. You could write it like this here, only you have to really write out a whole bunch of limits. Okay, let's move on to the next problem. Graph the function, find all the asymptotes, list the x and y intercepts. Okay, so let's start with the asymptotes and then the intercepts, and that will help us figure out which one's the right graph here. Okay, so first off, the asymptotes. We just talked about those. The horizontal asymptote, you see there's a larger exponent in the denominator again. So guess what? It's at y equals 0 again. For the vertical asymptotes, you have to factor the denominator. Okay, and remember, you want to see if any of these factors will cancel with the numerator, because there could be a hole potentially. So factor the denominator, and so if we factor x squared minus 4x minus 5 correctly, you would have x and x, okay, to give you the x squared. The signs have to be different to give you minus 5, and you have to have more negatives, so it'd be minus 5 and plus 1. Okay, now that is factored correctly. Okay, and then from there we can say that we have vertical asymptotes at x equals 5 and x equals negative 1. Okie dokie. So no holes in this graph. Now if this was x plus 5, okay, that would mean that we would have a hole at x equals negative 5, just to remind you of that. Now, how do we get the x and y intercepts? Well, very simply. Okay, so the x-intercept, to find the x-intercept, you let the top part be equal to 0. So you set the numerator be equal to 0, and that will tell you where y is equal to 0 at. So x plus 5 equals 0, so you would have an x-intercept at negative 5. Okay, and for the y-intercept, all you'd have to do is plug 0 into the function for x. So you would have 0 plus 5 on the top. So you would have 5 left up on the top. And then on the bottom, you would have 0 squared minus 4 times 0. So those two cancel. So it'd be 5 divided by negative 5. So your y-intercept is negative 1. All right, now with all that information, you can now figure out which one's the correct graph, hopefully. You want to look for the vertical asymptotes first to kind of cut things down. You have 5 and negative 1. So looking at this one has the vertical asymptote at 5 and negative 1. So does this one. This one's not right. This one's not right. Okay, so now let's see which one has the right intercepts. Y-intercept at negative 1. This one has a y-intercept at negative 1. Yep. This one doesn't. So that means it has to be choice A. But you might be wondering, what about the x-intercept? Well, it could be there. It's hard to tell because the graph isn't zoomed in. But these two choices definitely don't have an x-intercept at negative 5. So anyhow, let's move on to the next one. Once again, find the intercepts, vertical asymptotes, and the end behavior asymptote. Okay, so let's start with the intercepts. So talking about the x-intercept, remember the x-intercept, we're going to let the top be equal to 0. So we have x to the 4th plus 3 equals 0. Now, you want to figure out what x value here would give you 0. Well, you might not know how to solve an x to the 4th equation. So let's just try to get x to the 4th by itself. And then you could solve an x to the 4th equation by taking the 4th root of each side. Well, what's the 4th root of negative 3? Well, nothing, because a number raised to the 4th power can never be negative. So there is none. There's no x-intercept in this particular one. The y-intercepts. The y-intercepts, remember, you just plug in 0, okay, into the function for all the x's. So you're doing h of 0. So the y value, so you're figuring out the y value when x is equal to 0. So y is equal to 0 plus 3 is 3. 0 plus 1 is 1, so y is equal to 3. There's your y-intercept. Okay, now what are the asymptotes? Let's talk about the vertical asymptote first, because that one's easy. Set the denominator equal to 0, x equals negative 1. All right, this doesn't need to be factored, which is nice. Now, as for the horizontal asymptote, well, there is none, because the top exponent is bigger than the bottom. However, another type of end behavior asymptote is a slant asymptote, or really, it's not really a slant asymptote, it's a type of function that the graph approaches. And so we're going to figure out what function that is by doing synthetic division. You could do long division as well. So since we're doing synthetic division, we can do synthetic division because this is just x plus 1 and not like x squared or x cubed. So we're going to put negative 1 in the box because that's what would give you 0 here on these terms. And then we're going to make sure to put one of each of the exponents in decreasing degree from 4. So we put a 1, the leading coefficient here is 1. There is 0x cubed, 0x squared, 0x, and then put a 3 here, okay? And so now if we do synthetic division, we'd bring down the 1. Negative 1 times 1 is negative 1. So this would be negative 1 when we add them up. So we get a positive 1, 0 plus 1 is 1. Negative 1 times 1 is negative 1. And then you'd have negative 1 here. And then negative 1 times negative 1 is 1. And so that's 1. And then the remainder would be 4. Okay. Now, the remainder doesn't really matter for this end behavior asymptote because it's so, this is the end behavior, so it doesn't, the remainder is so small it doesn't really affect anything later on. So the end behavior asymptote here would be x cubed from this 1 here that we got minus x squared, okay, from that next minus 1 plus x minus 1. Okay, so that's kind of weird, but that would be the function that the graph approaches as x goes to infinity or negative infinity. Okay, same really idea on this particular problem here that some people had issues with. You just got to do synthetic division to find the end behavior asymptote, and you could do regular division as well. Okay, now if you're doing regular division, let me just show you how to set that up. You're going to do x plus 2, and then make sure, once again, you put one of each degree underneath the division bar here. Okay, plus 0x plus 1. Okay, so if you're doing regular division, you'd set it up like this. You'd take x into x cubed. So x goes into x cubed, x squared times, because you're really subtracting the exponents. 3 minus 1 is 2. Then you would multiply, so this would be plus 2x squared, okay? And then x times x is x cubed. And then you'd have to subtract, so you'd change your signs here. And so you'd have minus 3x squared. Bring down the 0x, keep dividing here. Okay, x goes into negative 3x squared minus 3x times. And keep going, and eventually you'll get x squared minus 3x plus 6. Once again, you completely disregard the remainder. That's not really important for the end behavior because, a remainder is really tiny, and you're looking at what the graph is doing as x goes to infinity and negative infinity. Okay? And so then you have to pick the right graph here. Okay? So since this is the function, it's going to be a happy parabola as the graph goes to infinity and negative infinity. Letter A doesn't show the graph actually going towards that parabola, so that's not correct. Letter B is a sad parabola. Okay, so the dotted line represents the asymptote here in these pictures, if you're wondering. Okay, so these two aren't right because they're sad parabolas, the dotted line. See, sad, sad. This one is the correct one because the graph is actually approaching the asymptote as x is getting really big and as x is getting really small. Okay, so hopefully that helps you understand those a little better. I'm going to give you a couple more practice ones, not too many because I'm really out of practice ones to give you, and hope you guys have a great day. Thanks for watching. Bye-bye.